Today we start our discussion about the Spring framework, which is one of the most popular Java web application frameworks. I think what sets Spring apart from other frameworks like Struts, Tapestry, JSF, GWT, and so on is that it goes beyond just web development. In fact, in this lesson and the next, we'll use Spring in regular Java programs, not web applications. We'll see that the concepts and technologies used in Spring, like inversion of control, aspect-oriented programming, decorative transaction management, and so on, are not only just for web applications, but also useful for all applications. I think this makes Spring a perfect fit for this class, because, as I said at the beginning of the class, this class is about web development, but not just web development. Our real goal is to study concepts and techniques for developing large, complex software, and for that, there's a lot in Spring that we can learn. Spring was started by the developer Rod Johnson. At that time, he was doing some consulting work on Enterprise Java Beans, or EJB, which was kind of the official enterprise web application framework by Sun at that time. Sun, by the way, was a big server and workstation company that also invented the Java programming language. After a while, Rod Johnson realized that EJB had lots of problems, and because these problems were at the design level, and because EJB was a standard controlled by a committee, there was no easy way to fix these problems. So he decided to write his own framework called Spring. At that time, it was one of the many so-called lightweight web application frameworks. Lightweight means it doesn't rely on an EJB container. And today, it's one of the few that are still being widely used and actively developed. Over the years, Rod Johnson wrote a number of books about Spring. None recently, though, as he probably is busy making money from Spring development. Technically, these books are already outdated, but they show the evolution of the framework, which you can kind of tell just by looking at the book titles. At first, it pretended to be J2EE, but then it lost some pretension by saying it didn't really use EJB, and then there's no more mentioning of J2EE. It's now just Spring. Spring is a fairly complex framework. As we can see in this figure, it has lots of components covering various aspects of software development. In this class, we'll touch upon most of those components, but today we'll focus on the bin container component, which supports something called inversion of control. Let's first use an example to motivate the need for inversion of control in software development. In our last homework, we did step 3 and 4 in the Spring and Hibernate from scratch example. You've seen this DAO example. In this example, we have a model class called user, and we have an interface called user DAO, which defines two operations. One is to get a user object given an integer user ID, and the other one retrieve all user objects as a list of users. And we have an implementation of user DAO using JPA. And this is how we can use user DAO in a controller. So what is this DAO thing? DAO is a design pattern called data access object. A design pattern, by the way, is a software design best practice to solve a particular problem. And the problem here is accessing data in some persistent data storage, like a database. As shown in the picture here, DAO sits between the application and the data storage, and provides operations to get data objects in and out of the data storage. By having this middle layer, the application code becomes independent of the data storage. For example, the controller here only needs to know that it can call getUsers to retrieve all user objects. The controller doesn't need to know whether the objects are stored in a relational database or object-oriented database or even just some files. And it doesn't need to know whether the database is MySQL, Postgres, or Oracle, or Microsoft SQL Server, and it doesn't even need to know whether the data access implementation is using JDBC or Hibernate or something else. By having this separation, as well as similar separations elsewhere in an application, we can divide an application into components that can be independently developed, tested, optimized, or even replaced, and that makes building a complex application a lot easier. In Java, DAO is usually split into a DAO interface and a DAO implementation, which means that there are two ways to instantiate that DAO object. You can use either the interface as the type, like this, or you can use the implementation as a type like this. So which one is better? The answer is, of course, using the interface as a type. And that's because this ensures that the rest of the code will only depend on the methods available in the interface. So if later we change to a different implementation, the rest of the code that uses user DAO does not need to be changed. And this is, by the way, also why when you use something like a list, you should always do this. Instead of saying array list and then something. Now that I said the rest of the code that uses user DAO, but what about this line of code that actually instantiates user DAO object itself? It turns out that the application is not really independent of the DAO implementation, because we must specify the implementation to instantiate a user DAO object. If we want to switch to a different implementation, we'll have to change all the controllers that has this line of code, and that can be quite a lot. This is actually an even bigger problem than it sounds. It's not just about changing the work or the time it takes to change the code. Imagine that during development, we want to use a mock DAO for testing purpose. For example, we may want to use a user DAO that always returns 2 pre-created users when getUsers is called. With the way the DAO is instantiated, it's very difficult to switch back and forth between different implementations, which makes testing with mock implementations practically impossible. So what can we do? Well, consider something like this. Instead of instantiating a DAO object in a controller, let's create a setter for the DAO in the controller. So now the controller is truly independent of the DAO implementation, as it will use whatever implementation passed to this controller through this setter. Now this looks pretty good, except for one important question. Now who's going to call this setter to pass a DAO implementation to this controller? Well, the answer is a framework like Spring, which will be responsible for instantiating the objects and pass them to application code. These types of frameworks are often called inversion of control containers, or just bin containers. And the term inversion of control means that it used to be the application code that's responsible for instantiating objects like DAO. But now the application code no longer has that control, and that control is somehow inverted to the framework which now responsible for creating or instantiating those objects. Now, the term inversion of control is not particularly intuitive. In fact, it's it sounds kind of odd because it's not so much of an inverted control rather than control being moved from application to framework. A generally more popular and more intuitive term is dependency injection. So, for example, here, user.dal is something this controller depends on, and the framework will inject a user.dal implementation into this controller by calling the user.dal setter. So, dependency injection or inversion of control are roughly means the same thing or equivalent terms, but dependency injection is probably more intuitive. Now, let's look at a simple example and see how it works. I have a simple Java class here called message, and this message has a property content. Notice that we have getter and setter here, and remember that getter and setter define a property. Here I have a main method, and inside the main method I created a message object, and then I printed out the content of the message. If we run this code, we can see that the content is hello world. Note that we didn't set the content of the message anywhere in the code. So where does the value hello world come from? It, of course, comes from Spring, and more specifically, the Spring bin configuration file hello world.xml. In this file, as we can see, we define a bin called MSG bin, which is of this message class, and we set the content property to the value hello world. And in the main method, we load this bin configuration file and create something called an application context. Think of an application context as a container that contains all the bins managed by Spring. And then we use the bin ID MSG bin, which we specified here, to get the bin from the application context. And then we print out the content property of the bin, which is set to hello world in the bin configuration file. And this is why when we run this code, we see hello world here. And of course, if we change something here, we can say hello CS520. And if we run the code again, it will say CS520. So in this example, we can say that the string value hello world is injected into the bin MSG bin, and it's a very simple example of this dependency injection. Now let's understand how this injection happens. First, consider how we usually create a new object. For example, suppose we want to create a new message object. Usually we would say new message, or in other words, calling the constructor of the message class. The Java virtual machine will process this call of the message constructor and return a message object. Notice that because we didn't do anything in this constructor, if we create a message object this way, the content property of the message object will be null. Now let's see how it works with Spring. The first thing to note is that with Spring, we don't use the constructor to create an object. See here, we are not calling the constructor new message. Instead, we create the object through Spring using getBin. So when getBin is called, Spring will look up the bin configuration file, and based on the bin ID MSG bin here, it will find the bin configuration. And from here, it will know that this bin is of the message class. So Spring will call the constructor of the message class and create a message object. And then, because the bin configuration file also shows that the property content should be set to hello world, Spring will call the setter of the content property and then set hello world to the message object. And then getBin returns and the application code get the message object. So now we have a message object that has a content property with the value hello world. The key thing to note here is that it's the Spring who's calling the new message constructor, and the application code use getBin to create that object, or a bin as is typically called. Now, this may sound like an awfully complicated way to set a string property, but of course Spring can do a lot more than this. Not only it can inject simple types like strings and numbers, it can also inject collection types like lists, sets, and maps, and most importantly, it can inject bins into other bins, which makes the framework very flexible and powerful. In terms of ways of injection, the most commonly used is through setters, but Spring can also do injections through constructors. Now, let's see another example. In this example, we'll see the injection of simple types, collection types, and class types. In this example, again, I have a bin class, and in this class, I have some integer properties A, B, C, D. By the way, all those properties have their getters and setters, so I'll only show the fields here. I also have an array property called numbers, which is an array of integers. And I also have a date property called Null, which is of date type. And inside the main class, inside the main method, I load a bin configuration file called dj.xml, and I create an object of this dj bin type, and then I call output. So the output method will print out the properties A, B, C, and D, and it will print out the sum of the numbers properties, and it will also print out the date property now. So it basically does a printout of all the properties. So what's in the bin configuration file then? And here we can see that we have a bin called DJ, which is this DJ bin type, and we're injecting various values into different properties. The first two are injecting through the constructor. Notice that the constructor takes two arguments, and the first one is assigned to property C, and the second one is assigned to property D. Now, to inject into C and D through constructor, we specify the index of the argument. So 0 is the first argument, 1 is the second argument, and then the first argument is 15, second argument is 40. So in other words, C should get the value of 15, D should get the value of 40. And then we inject values 10 and 20 into property A and B, and then we inject a list of integers into the property numbers, and then we create another bin which is called date, and it's a Java date type, and we inject that bin into the bin called DJ. So if we run this code, we can see that A is 10, B is 20, A is 10, B is 20, C and D are 15 and 40, and the sum of the numbers array is 3, 1 plus 2, and the date value is null, which is the value when we call the constructor of the date class. If we change this one, for example, to 1, 2, 3, and if we change A to 1 and run again, we can see A is 1, and now the sum of this array is 6. And by the way, array, as we can see, is injected using a list element, and the value now is this. So as you can see, in Spring, a bin configuration file actually is not very difficult to create, and the syntax to specify bins and the properties are pretty straightforward. Here's a summary of the common elements and the attributes used in a bin configuration file. For a bin class, we use bin and then ID and the class. ID is like the name of the bin, and class is of course the type of the bin. And for simple type properties like strings and numbers, we use property and then the name of the property and the value of the property. If a property is of a class type, like a date type, in this example, we still use property and name, but this time, instead of value, we use reference. Reference is the value of reference attribute should be the ID of another bin. So here, for example, we say reference and the date being the ID of another bin. And we can inject collection types like a list of something, a set of something, maps, properties, and so on. And we can use constructor arg to inject values through constructor arguments, with index being the index of the argument. And then we either use value or we use reference, depending on whether that constructor argument is a simple type or a class type. Here are a few additional examples of setting collection properties. We've seen an example here setting list or array, and here we have an example of setting a set of values, and here is a map, and here is a Java properties. By the way, in case you don't know, in Java there's a properties class, and the object of properties class can hold a list of key and value pairs usually used for configuration purposes. So here we can set a Java properties object, and that properties object would have two properties, each with a key and a value. Key and value. In Spring, the most interesting thing to do, of course, is to inject bins into other bins, and that's called wiring in Spring, because it's like creating a a bunch of beans and then wire them or connect them together. Now let's use a more complex example and see how wiring works and how it helps with software development. Here I have an interface called stack. If you remember your data structure class, you'll remember that a stack is a so-called abstract data structure, and a stack has two basic operations, push and pop. And also a stack is a so-called first in, last out, or last in, first out data structure, meaning that if we call push, 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 and push 3 values into a stack, and then we pop those values out, the last one will be pop out first, and then the second to last, and the first one will be pop out last. So here is an interface of stack, and it just defines the two operations with no implementation. Now here is an implementation of stack, and it's called stack 1. So in this implementation, we implement both push and pop, and internally it uses an array list to implement this stack. The implementation itself doesn't matter that much. The important thing here is to remember that this implementation uses a hard-coded array list of strings to implement a stack. So here I have some test code which presumably will test the implementation of a stack, and the test method will try to push 3 strings into the stack and then call pop 3 times. So the order of push is 1, 2, 3, and if the implementation works correctly, the printout should be 3, 2, 1, because again, stack is first in, last out, or last in, first out. So if you look at the code, it looks very much like what we've seen so far, as for example in the hello world example, where instead of creating a stack object directly, instead of creating a stack test object directly, we try to create that through Spring by calling getBean. And once we get a stack test object, we call the test method, and then it should print out something. Now, if we look at that Spring Bean configuration file, stack.xml, we can see that we define a bean here called stack test, and it's here. So it seems like everything is in order, so we can try to run this. And we get a null pointer exception. So if we look at the exception, we can see that the exception happens here, and it says null pointer, and that means stack variable here is actually null. And the reason for that is, of course, not surprising, because we declared a stack field here, but nowhere in this code that I actually instantiate a stack object, right? So stack declared here, but there's a setter for stack, but we never really instantiate stack, and of course we are going to get a null pointer exception. So doing things the Spring way, we are not going to instantiate stack directly inside the application code. I'm going to do it here. So what this means is that I have a stack property here. So it will be property name is stack, and we need to pass something to this stack property, right? So let's say that we want to create a stack1 bin and wire that bin into stack test. So what we can do is we can say bin id, and I'm going to create a stack1 bin. And remember how we can inject a class type into another bin, and that's using reference instead of value, right? So here it's ref, and we are going to reference the ID of this bin, and that's stack1. So stack1, notice that it doesn't have other dependencies because it has a hard-coded array list inside the class. So there's no property necessary for this one, and here we inject this bin into stack test. Now if we run the code again, it says required type stack. Oh, sorry, wrong class. This one should be stack1, not stack test. Otherwise, we will be injecting stack test into stack test. Okay, so now it works, and in fact, it works correctly. Notice that it's 1, 2, 3, and the output is 3, 2, 1. So this is a simple example of wiring. We have two bins, and we wire one of them into the other. Now, let's say that I'm not happy with stack1, which uses a hard-coded array list inside the class to implement the stack. Maybe, for example, I want to replace it using a different implementation, and this implementation would have the flexibility of choosing different list implementations to use. Maybe I first want to try array list. If array list for some reason doesn't give us the best performance, maybe I want to try a different implementation of list, like a linked list. Maybe a linked list will give us better implementation, and so on. So let's try to do something like this. I already have the code here, which I call stack2. If you compare stack1 and stack2, you can see that the difference is stack1 has a hard-coded array list, and the stack2 doesn't have that. What stack2 has instead is a setter called setList, and presumably the framework will pass list implementation to stack2, so that stack2 can use it to implement the stack. Again, notice that in stack2 we declare a list, but there's no instantiation of that list. We have a setter, and we want the framework to pass us an implementation through the setter. So if we want to do something like this, we just need to change the configuration file a little bit. So instead of stack1, we are going to have stack2. Instead of injecting stack1 into stack test, I'm going to inject stack2 into stack test. So notice that if I run this, if we run this right now, we are going to have another null pointer exception because the list field in stack2 is not initialized anywhere in the code, right? So what we do is we need to pass we need to set the property, and that property, by the way, is called list. This is a getter, and the property name is lowercase l list. And because it's a class type, so again, it's going to reference something. To reference what then? Well, we'll create a array list bin and a linked list bin, and we'll try both. So we'll say, let's create a bin called array list, and the type or the class of that bin is Java utility array list. And that's, by the way, where is it? It's this class. And similarly, we can also create another bin called linked list. And then we can say, let's inject array list first. So now we're basically doing this. Array list inject into stack 2, and in stack 2 inject it into stack test here. And if we run this code, it works. And if for whatever reason we are not happy with array list, we can say, okay, let's then try linked list or list bin, and it still works. So as we can see, by changing just one configuration file, we have lots of flexibility to pick which implementation we want to inject into which bin, and we can do fairly complex wiring like this. And this is all pretty nice, except that the bin configuration file, if we look at this, the bin configuration file can get quite complex when we have more than just a handful of bins. So Spring supports another way to specify bins, and it's using annotations. To use annotations in Java code to specify bins, we have to change the bin configuration file a little bit. So it looks like this. In the bin configuration file, we need to have a tag called Annotation Config, and this tells Spring that we'll be using annotations to configure our bins. And we need a tag called Components Scan. And this tag tells Spring to scan certain classes to look for those annotations. And then in each bin class, we use some annotations like @component to indicate that that class should be considered as a bin class, and then we can wire bins together using annotations like auto wired. Now let's go over this one by one. First, the bin configuration file. And here I'd like to take a little time to talk about XML namespaces. We know that XML file consists of XML elements like these ones, and usually we call them tags. The problem is that different developers or organizations may create different tags that have the same name. For example, Spring may create a tag called bins or bins, and I could also create a tag called bins that means something else. So to deal with this problem, XML uses something called Xml Namespace. By combining the name of a tag and the namespace of the tag, we can make sure that the tag is unique. Note that this is very similar to custom tags that we used in JSP. Remember that a custom tag like cif is a combination of the tag library and the tag name, and that ensures that the tag is unique. XML namespace is basically tag libraries for XML tags. Now let's look at the syntax of using XML namespace. First, notice that this bin configuration file uses three namespaces: bins, context, and XML schema instance. Each namespace is represented by a URI, this one, and this one. And notice that this is exactly the same as using URI to represent a custom tag library. Now, in this bin configuration file, the bins namespace is a default namespace. Notice that it says XML namespace is this one. What this means is that any tag from this namespace does not need a prefix. So when we say bins and the bins tag is from this namespace, it doesn't need a prefix. But any tags from the other namespaces need to be prefixed by the namespace name. For example, the Annotation Config Tag is from the context namespace, so it needs to be written as context column annotation config, and similarly, component scan needs to be written as component scan because it comes from this namespace and it's not the default namespace. And here's another way to write exactly the same file except using different default namespace. For example, notice that this time the default namespace is context. Now, annotation config and component scan no longer need a prefix, but now the bins tag needs a bins prefix because now this bins namespace is no longer the default namespace. Once you understand the namespacing, it's much easier when you read Spring bin configuration files. So understand what it means. Now, moving on, and let's see what these tags do. First, the Annotation Config Tag activates the processing of a number of annotations, like auto-wired, qualifier, resource, persistence, context, and so on. And we'll explain them in a moment. The component scan tag tells Spring to scan all the classes under the base package as well as all the packages under the base package. For example, here it says the base package is cs520.spring.stack. It means that Spring then will scan all the classes under this package plus all the subpackages under this package. In other words, in our case, it will scan all the Java files in this package, all the Java classes in the package. So what does Spring do when it scans a class? Well, it will look for one of these annotations to determine whether the class should be considered a Spring bin. For regular bin classes, we use the annotation component. For DAO classes, we use the annotation repository. For controller classes, we use the annotation controller, and for service classes, we use the annotation service. Once those classes are annotated and once the bins are created from them, Spring can automatically wire bins together. There are two basic types of auto-wiring. by bin name and by bin type. And by type is the default wiring auto-wire type. There are also two additional types of auto-wiring. Auto-detect means Spring will try both by name and by type until it finds a suitable bin. And constructor means the bin will be wired by type as a constructor argument. And we can specify auto-wiring type on a per bin basis or for all the bins. If a property needs to be auto-wired, we can use the auto-wired annotation. And sometimes we can also use a couple of other annotations, qualifier and resource, and we'll see how all of this can be put together and make things work. So again, going back to our stack test and stack 1 example. So now we're going to use annotations to wire those bins, create and wire those bins. And so instead of using stack test, which uses a stack.xml bin configuration file, we're going to use stack test annotation, which uses stack annotation.xml as the configuration bin configuration. So here we activate annotation and we do component scan, but we don't have any annotation in the class yet. So let's say we want to do something like this: stack test bin and then stack 1 bin. So we first make stack test a bin, and remember that to do that we use an annotation like this, and it's just a regular bin. It's not a DAO or controller or service class, so we simply say component, and then we need to make stack a bin 2, so we say stack we say component for stack 1. And if we run this code, we'll get an error, and once again it says stack is null, because although we have created 2 bins, we haven't wired them together yet. So to wire them together, we use auto-wired. We'll say auto-wired, and then if we run this again, it will work. So what's happening is that by using these 2 annotations, we create 2 components, and then we say auto-wired, and then Spring will do auto-wire by type, and it will look through all the bins and try to find a bin that is of the stack type, and it will find stack 1 bin, which is indeed of stack type, and it will wire stack 1 into stack test here, and that's pretty great. Okay, so let's say now we want to do this. Instead of wiring stack 1, I want to wire stack 2 plus something else. And so we'll make stack 2 also a bin by annotating it with component. And if we run this again, we'll see an error, and when we see an error, we'll look at the error message carefully, which most of the students tend to not to do. Okay, so what's the important message here? The important message here is that no unique bin of type stack So what this means is here we want Spring to auto-wire a stack bin here. However, both stack 1 and stack 2 implement stack interface, right? In other words, we have two bins both fit this requirement, and that's why we're getting an error that says no unique bin of type stack. Now, to pick the right bin, we can use the qualifier annotation, and we'll say, let's give it a qualifier, and we'll say qualifier. We'll say of those two stack bins, I want the one that's called stack 2. So if we run this, we'll see another error, and this time it's because stack 2 needs a dependency itself. So remember what we did before was to create a bin and then inject this bin into stack 2. And we can do the same thing. So we'll create a bin here. And notice that you can combine using annotations and explicit bin definition in the bin configuration file. So annotations can be used to create those stack and stack test bins, and then we can create additional bins just like before. So here we create an array list, and then we say let's wire that into stack 2, and if we run that unfortunately still doesn't work, and the error message says no matching bin of type string found in collection of Java string, and so on and so forth. So this error message is different from before. The error message we had before was we had two bins that both implement the same type, but this time we didn't find anything. And the reason it didn't find anything is that it asked for a list of string here, and here this array list bin is not a list of string, it's actually a list of so-called raw types. So if you remember Java generics, the way if you create array list like this, it's a list of raw types, it's not a list of strings. So Spring does not automatically consider this one fits the bill for this one. So instead of saying auto-wired, which would do auto-wiring by type, instead we can say resource. So we'll tell Spring that, hey, I'm going to use this bin called array list, and don't complain about that. And now it finally works. And this is how we can do this using just annotations and auto-wiring, and of course one more additional bin. Okay, to summarize, there are quite a few advantages of using inversion of control, and the most important which is the true separation of different components of an application. For example, the controllers and the DAOs, or the implementations of a data structure with the code that uses that data structure. Now, this separation allows those components to be independently developed, tested, optimized, and replaced, and that's tremendously beneficial to complex software projects. Also, with IOC, the dependencies or the wiring of the bins are centralized in one bin configuration file. So if we want to replace some bins or components, we just need to edit one configuration file instead of lots of source code files. And finally, Spring bins are by default singleton objects, meaning that once a bin is created, it's shared by all the code that uses a bin. Performance-wise, this is quite beneficial as we don't need to recreate an object again and again. And of course, if you do want to create a new copy of a bin every time it's used, you can also do that with Spring. In Spring, those types of bins are called prototype bins as opposed to the regular singleton bins by default. In this lesson, we introduce Spring Framework's bin container and how to create bin configuration files and wire bins together. For more information, please check out the first 3 chapters of the Spring in Action book, as well as Spring's documentation on the Inversion of Control container.